Hello scholars, it's Edumat Hub. You're welcome to the channel. In today's video, I'll be taking you guys on the basics of organic chemistry for your Jamb 2025. It's going to be a quick rundown overview of this very important topic. This is a very key topic for Jamb. Okay, Jamb cannot do without certain questions on organic chemistry, but if you don't understand the basics, it's going to give you as much of a challenge. But in this video, I can assure you that I'm going to give you some 1 or 2 tips that will help you to understand the basics of this topic. It's a very simple topic, just that students are always afraid of it. But I'm going to break it down for you and you're going to understand it. Okay, just stick with me as I proceed. Okay, so I'm going to start with the first part, which is basically just the definition of organic chemistry. So organic chemistry is the study of the preparation, structure, properties, composition, and reaction of organic compounds. Okay, now it's a branch of chemistry separate from inorganic chemistry. Inorganic chemistry, when you talk about things like mineral acids, compounds of nitrogen, compounds of sulfur, other aspects of inorganic chemistry. But in this one, you're talking about majorly compounds of carbon. Okay, the organic compounds of carbon, aside the oxides like all the CO2, you're less concerned about that. So talking about compounds of carbon that involves carbon, hydrogen, there may be oxygen, nitrogen, and so on. These are all organic compounds. So that's what we'll be focusing on this particular branch of chemistry, which is organic chemistry. So this part of chemistry deals with the preparation, how to prepare, the structure, what these compounds look like, the properties, the chemical or the physical properties, how these compounds behave. Are they liquids at room temperature? Are they gases at room temperature? How do they react? Okay, that's about the reaction of organic compounds. So that's the branch of chemistry that this is called organic chemistry. Now, the next part is talking about organic compounds now. So what's an organic compound? Most of the organic compounds are found in animals and plants. Okay, both living and dead. So anything organic means that it can be found in plants or animals. So when something is inorganic, that means it is not obtained from plants, it is not obtained from animals. So that's the basic idea behind that part. So organic compounds are majorly obtained from plants and animals. Now, what are the importance of organic chemistry? Now, organic chemistry is very important to life because if you look at the synthesis of major important compounds in the body, they are all organic in nature. All living organisms are made up of millions of organic compounds. Okay, so carbon is a the most important compound when you're talking about organic chemistry because carbon is found in all organic compounds. So it's very important in medicine. Organic compounds are also used in making medicines for treating various illnesses. Then you have organic compounds in the textile industry. Now, in the textile industry, clothes are made from organic compounds called fibers. This will teach you the basic of organic chemistry, so stick with me. After this class, I can assure you that you'll be able to answer a lot of chemistry questions in your Jamb. So clothes are made from organic compounds called fibers. Organic compounds also serve as a source of energy. Fossil fuels such as coal, petroleum, and natural gas. Gas is majorly methane. This compound is called methane, which is an alkane. I'm still getting there, so don't be confused yet. I'm going to teach you how to draw this structure and how to name these compounds. It's very simple. So natural gas, like your gas cooker at home, what you normally cook with, they are majorly alkanes like butane, propane. Butane is C4H10. I'm going to teach you how this formula is derived later. Okay, just know that organic compounds can be used as energy or fossil fuels. Then you also have plastic products. Now, organic compounds are used to manufacture plastic items. All the plastics that you have in your house, like your normal pan, plates, and other things, they are all organic in nature. When you burn these things, like when these things burn, you notice that the smoke is black, like thick black. That's to tell you that carbon is present in that compound. So it's organic in nature. You also have harmful effects of organic compounds. Organic compounds are also harmful. Okay, now insecticides, for example, If you check the container of most insecticides, you always see some big names. So something like dichlorphenyl trichloroethane, which is called DDT. It's a popular compound in um, insecticides. It is harmful to insects, but it is harmful to insects. It's also harmful to human beings too. So you need to be very careful. That's why it is written there that you don't spray it near infants, or as in don't be there after when you spray insecticide. You don't stay in the same room because it's very dangerous. You also have CFCs. CFCs is the acronym for chlorofluorocarbons, okay, which contributes to global warming. Now I'm going to explain this later when I get to how CFC is generated. CFC is actually used as refrigerant. So it is present in like all these perfumes, like when you spray perfume, CFC is present in it. CFC is chlorofluorocarbon. It's also common in refrigerants, like all these like in your refrigerator. What actually constitutes that cooling effect is CFC, which is chlorofluorocarbon. And when these things get to the atmosphere, they cause global warming. They cause the atmosphere to trap heat. Instead of the heat escaping, the heat is not trapped in the atmosphere. That is what causes global warming. The atmosphere becomes hot. They also have plastic materials such as polythenes. Okay, and these polythenes do not decompose easily. Take for example, pure water nylon. It doesn't decompose easily. That's why they serve as they can cause environmental pollution because they do not decompose easily. Bacteria and other microorganisms cannot act on them. Plastic is non-biodegradable because it is very hard for plastic to decay. You understand? It's very hard for plastic to decay. Let's take the next one, which is the origin of organic compounds. Where are these organic compounds obtained from? I told you that the word organic, if something is organic, like when you see that word organic, it means that thing is either obtained from a plant or it is obtained from an animal. So that's the idea behind organic. So these organic compounds are majorly obtained from living organisms, synthetic compounds, and prehistoric sources. Prehistoric sources are like all these old dinosaurs. All these dinosaurs that have died, old plants that have died for millions of years. When they decompose, they give off certain gases. Okay, even their remnants also produces different kind of compounds, and these compounds are organic in nature because they are produced from living things. Those things were actually alive before. Okay, so these are the three major sources of organic compounds. Now, for prehistoric sources, talk about things like coal, petroleum, and natural gas. They are sources of organic compounds. For living organisms, you talk about you and I, plants and animals, every living thing that are existing right now, including animals and plants. Then synthetic compounds are prepared in factories and laboratories through various processes. Now, if something is synthetic, that means it was manufactured, it was made. It's not natural, it was made, it was synthesized. If something is synthesized, that means that thing was made by mixing one or two things together. So you can also manufacture organic compounds like that in the laboratory. Now, synthetic organic compounds and their uses. The first one you have is polyester. So polyester is used in making clothing items. That's polyester for you. Then the next one is polyvinyl chloride, which is normally called PP. So it's for making clothing, blankets, and carpets. You know this carpet that is like how would I put it? It's not actually plastic, but it's just very flexible. That common carpet that they sell in the market, it's just like clothes, but it's not actually clothes. So it has PVC material. So you can use to make blankets and carpets. Then you have perspex. Perspex is used as a substitute for glass in aircrafts and in buildings. Then you have polythene. All of you know polythene bag. Okay, normally called poly bag. That's packaging for packaging materials, for baskets, for cups. These disposable cups. This red type. That's polythene. Then you have polychloroethane, commonly used as polyvinyl chloride too, and it's used to make water pipes. Okay, water pipes, electrical appliances like the body of radios and a substitute for leather. Then you have neoprene. Neoprene is naturally used as a substitute for rubber. Okay, substitute for rubber. That's neoprene. So take note of the spelling because it can be kind of confusing. So you need to take note of that. So let's move on to the next part, which is the fractional distillation of organic compounds. Now, I told you just recently that these organic compounds are actually obtained from, you can see from here, they can be obtained from prehistoric sources. So one of those prehistoric sources is crude oil. Organic compounds are obtained from crude oil, and that process is called fractional distillation. Now, when do you use fractional distillation? When you have a mixture. Mixture are compounds like that. They are not chemically reacting. They are just mixed. So they are physically combined. Just like you add, when you put gari plus water, it's like a mixture. Okay. Or when you put stone and iron filings, that's a mixture. Same thing here. You have crude oil. Crude oil is a mixture of different organic compounds. Now these different organic compounds have different boiling points. So because they have different boiling points, most of them will boil off or evaporate at different temperatures. So using that concept, you can use the concept of fractional distillation to separate them. So fractional distillation is the process of separating a mixture of components of crude oil by using that difference in boiling point. Because they have different boiling points, then you'll be able to separate them. The crude oil contains a mixture of different types of organic compounds, as you can see. So crude oil is made up of different organic compounds. There's petrol there, there's bitumen, there's natural gas, and so on. There's diesel too. Now, let's look at the fractional process. Now, in this process of fractional distillation, the crude oil is heated to about 400 degrees C. Okay, and vapors are passed into fractionating columns. Now, these are the fractionating columns here. This part like this. These are the fractionating columns. You know that when something is a gas, if something is a gas in gaseous form rather, and you want to get it in the liquid form, you need to cool it. Okay, you need to cool it. And when you cool it, it becomes liquid. But if it's in liquid form, when you take it to gas, you need to apply heat. So in this first method, you need to remove it. You subtract heat from it. While in this one, you need to add heat plus heat to it. So using that idea, these parts here, these things here, they're like condensers. Okay, they're like condensers. All these ones here, they're like condensers. So using that idea, you now know that all these substances or these mixtures will come off at different temperatures. As you can see from here, you can see refining gas here. It is going off at a different temperature. Okay, the heat is moving to 400 degrees C. So as it's getting to 400 degrees C, you start from like 50, 60, 70, 80. At those temperatures, different substances are being given off. And those substances will move to their own fractionating column, where they will be, they will be converted back to their liquid form, or they will condense back to their natural liquid form. So this is one for petrol. Petrol will go off at 40 degrees C. So before the temperature gets to 100, you can see that petrol has already been distilled. Then here is naphtha. This is kerosene here, which is used for aircraft. Petrol is for planes and so on. Natural gas for candle for heating and so on like that. Then the next one is lubricating oil and so on. So you can see that it's the same temperature that is being given to everything, but each of them are going off at their different boiling points. The next one here is the components of crude oil. Now, components of crude oil, the first one here is fuel gas. Fuel gas has a boiling point. You can see it's very, very small. The temperature is very small, from minus 160 degrees C to 20 degrees C. And the number of carbon atoms is 4. That is why in your medicine, like the first member of the alkene series or alkene family, you have CH4, you have C2H6, you have C3H8, and you have C4H10. So these four guys are the first 4 members of the alkene family. This is a homologous series. I still getting there. Don't worry, don't be confused. It's very, very simple. Okay, let's stay with me. Stay with me. Okay, stay with me. Stay with me. Stay with me. Let's go. So this one here, these 4 members here, they're actually gases. They are used for heating. Okay, as fuel. Use them as fuel for cooking, basically, or as energy sources. So the number of carbon atom is 4. You can see from 1, 2, 3, and 4. That is why it is written here 1 to 4. because these first four members, they are gases, your normal cooking gas at home. Then you also have petrol. Petrol has a higher number of carbon atoms, starting from 5 to 10. So the one that has 5 carbon atoms is pentane. So pentane is C5H10. That's basically like petrol. Then you also have C6H12, as you can see from here. The higher the number of carbon atoms, then the state will now change to liquid. At first, when the number of carbon atoms is from 1 to 4, it will be like gas. It will be like in gaseous form. Sorry about that. It will be like in gaseous form. When the carbon atoms have now increased to like 5 to 10, it will now be as if they are in liquid form. You can see the higher the number of carbon atoms, the more they tend to appear as liquids. Then you also have naphtha or gasoline, which is also in liquid form, like 8 to 12. Then you have paraffin or kerosene. Kerosene is liquid, obviously. You have diesel oil. So as it's getting higher, they become more solidified. Bitumen is a solid. So you can see. So from more than 70 or from 70 upwards, then they appear in solid form. Bitumen is that black stuff that is used to grade roads, as in they put on top roads to make it look black. You can also see that lubricating oil, the viscosity, the way it flows, is kind of thick. It doesn't flow like fuel. Fuel is like, as in fuel flows freely, just like water. Though not like water, but it flows freely. But there's no resistance in between the particles. Okay. But in lubricating oil, it's like your normal red oil that slips after a while, as in the particles will coagulate and they will stick together. But lubricating oil, the viscosity is high. That's because the number of carbon atoms is high. Yet the number of carbon atoms is small. That's why they appear as a gas. So the higher the number of carbon atoms, the more the change of states from gas to liquid to solid. Okay. Now, uses of major components of crude oil. What are they used for? So this is the fraction here, which is the fraction just means that which parts of this guy are you talking about? Which parts of this product that is being distilled here? Which of them are you talking about? Is it kerosene? Is it diesel? Is it lubricating oil? Okay, is it residue and so on? So that's the fuel gas. That one is used for cooking, which is the one we just talked about. Okay, that part is basically your normal methane, butane, all those ones that you buy from filling station. Methane, butane, and those ones. Then petrol, we all know petrol now, though as things are going on in Nigeria now, everybody does the hustle, it's easy. So vehicle and solvents, things are expensive now in Nigeria. So because fuel is expensive, other things tend to be expensive. Even people that their market does not involve petrol. They will also say, fuel don't increase now, let me increase my own stuff too. We're not supposed to be like that, but that is the country we find ourselves in. Then naphtha. Naphtha is actually a chemical. Okay, it's a chemical. Then paraffin. That's what they use, all this candle material. So it's used as a jet engine and kerosene lamp. So you're seeing kerosene lamp, what they call atupa in Yoruba. Okay. Then there's diesel oil. Diesel oil is basically used as in diesel engines. Okay. Then you cannot use fuel for diesel engine to knock it off. That's because the number of carbon atoms is very high in diesel oil. That's why it can work. But if diesel oil is more viscous than normal fuel, sorry. So the number of carbon atoms is high. You also have lubricating oil. Lubricating oil is used as lubricant, like grease. What you can use to grease your clipper, moving parts of a generator, your door, and so on like that. The carbon atoms here is very, very high. You also have bitumen. Bitumen is basically in solid form. So they use it to make bitumen, fuels in shape, and lubricant oil, and for making waxes. All this wax figure. Okay, let's move to the next part, which is very, very important. Thank you for watching Edomat Hub. I'm really grateful. Without you guys, there's no Edomat. I really appreciate you guys. Thank you, thank you, thank you, thank you. Okay, let's continue. I hope you understand. If you don't understand, just let me know in the comment section. So if there's anything I can tackle, I'm here for support. Okay, you're helping me, and I'm also helping you. So any parts you don't understand, just let me know. I'm ready to take it up again. So let's take the next one, which is cracking. Now, cracking is the conversion of large molecules of organic compounds into molecules with smaller molecules. So you have a large organic compound, like take for example, you have C50, okay, H 102. the compound like this, you can see this is a very large organic compound. The structure will be very, if you draw the structure, is very crazy. That's 50, as in 50 carbon atoms. You have to do this C 50 times on a straight line. You understand? Now, this compound is very, the structure is very, very long. But when you break it down to something like, when it becomes C5H10, you can see from C50 it became C5. That process is called cracking. Cracking will help you to break a large organic molecule, okay, into a small molecule. Okay, and there are two methods of cracking. You have thermal cracking and catalytic cracking. Now, thermal, when you see thermal, that's not heat is involved. Anytime you see thermal, heat is involved. So thermal cracking is heat energy is used in cracking the large molecule of organic compound to smaller molecules of organic compound. That's thermal cracking. You're going to apply heat. But in catalytic cracking, you use a catalyst, okay, to break down the molecule of organic compound to smaller molecule. So you're just using the catalyst to speed up that reaction. Okay, use to speed up the reaction of the breakage of the large organic bonds in the larger structure to smaller organic bonds in the smaller structure. Okay, so you can see. So don't forget those two methods. Jamb can ask you. So take note of them. Then the terms used in organic chemistry. Now, the first thing you need to know in organic chemistry, you need to know what's called molecular formula. Molecular formula is a formula that indicates the type and number of atoms in a molecule. So something like this, for example, now C4H10 is butane. This is a molecular formula. This molecular formula C4H10. But if you look at this thing, you notice that 2, you can divide both sides by 2. As in 2 can go. This will be C2H5 if you divide by 2. Okay, so this one is not molecular formula. This one here is molecular formula. It shows you the exact number of atoms that are inside that structure. Okay, so it's a chemical formula indicating the types and number of atoms in a molecule. So it shows you that this contains 4 carbon atoms and 10 hydrogen atoms. The next one is structural formula. Structural formula will just give you a graphical overview. So you can see from here, it's a chemical formula which shows the arrangement of the atoms in the molecule. It shows you how they are arranged in space. It's called spatial geometric arrangement. So the structural formula can be shown in condensed form, can be condensed, and can be in an open formula. So I will give you this example. It's very, 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 very simple. Let me start with a simple one, which is like, let me start with C2. So let me use propane, C3H8. Now C3H8 is the formula of propane. So propane has 3 carbon atoms. So because it has 3 carbon atoms, you have to write it like this. So you're going to use straight chains. This thing I'm drawing here like this, it means 2 electrons are involved. Electron from here, electron from here. So when you see this line like this, just know that a pair of electrons are involved. This straight line like this. Okay, so these are the 3 carbon atoms that I've written here. The next thing is to insert these 8 hydrogen atoms. So I'm going to insert them like this on top the carbon. So I'm going to put H here, another H here, sorry, another H here, another H here, another H here. So you can see this structure now. If you count the hydrogen one, you have 1, 2, 3, 4, 5, 6, 7, 8. You can see you have 8 structures, 8 hydrogen atoms there. This is now the structural formula of this molecular formula here, which is called propane. So this one here is molecular formula. This diagram that you are seeing here, this geometric arrangement showing you the number of carbon atoms and number of hydrogen atoms involved, is what is called the structural formula. And it can also be in the condensed form. This one is the open structure. It's as if it has been opened, showing you the inside, as in what it looks like in the inside. But if you want to write this in the condensed form means you should shorten it. Now you just pick it like this. Let me change the color of the marker so you understand it better. So that condensed form is also simple to get, but you just change the way you pick the structure. So I'm going to pick it like this now, like this part like this. So if I pick only this part like this will be 1 carbon and 3 hydrogen, as you can see. So this will be CH8. 3. Then I'll come to this middle one here, do the same thing. This will be CH. I'll come to this one to do the same thing. This will be like this here. This will be CH3. So in this way, like this, the way it is like this is the condensed form of this opened form. This is condensed. That means you have shortened it. This one is the open form. So this one is CH3, CH, CH3. Okay, this is condensed form. This is what is called propane, condensed formula. Then if you continue, the next one is the isomer. So isomer compounds with the same molecular formula but different structural formula. So in isomers, you have two compounds. These two compounds, they have the same molecular formula, but their structure is different. So take for example, if you have butane, if this is butane, butane is 1, 2, 3, 4. These four carbon atoms like this. This last carbon atom can also be placed in this center here. This last one here, I can place it here like this. So it changes the structure from normal straight way like this to this way. So I'm going to explain to you better when I get to isomers. But just know that isomers are compounds that have the same structural formula, as in their formulas are the same, but structurally they look different. When you draw their structures, they look different. So that's that about isomers. So I'm going to break down that part when I get there. So take notes: same molecular formula, different structural formula. The next one is general formula. General formula is a formula that can help you to get the formula of any organic molecule as far as you know the family it belongs to. So that family is what is called the homologous series. Now the homologous series is an arrangement of members of a family of organic compounds in order. So the first homologous series, which is very, very common, which everybody knows, students like talking about, is the alkane. You're going to get there. But for now, you need to know the characteristic of the homologous series. Now, homologous series, all the members of a particular series can be represented by the same general formula. So I'm going to use alkane as an example, the alkane family. So this alkane family here. Alkane family is CN, H2N plus 2. This is the general formula for alkane family. So if you want to get the first member, that means N is 1. That's the meaning. N is 1. So if N is 1, let's put C1 here. This will be H. 2 times 1, 2. 2 plus 2 will be 4. So that will be C1H4. Or you can say CH4. This is the first member. This first member is called methane. Then the second member will be, just put 2 here. So that will be C2. Put another 2 here. 2 times 2 is 4. 4 plus 2 give you 6. So this one will be C2H6. This one here will be the second member. So and so on like that. You continue like that, you get the member. So this is the general formula for the alkane family. Now, let's go to the second property. The homologous series. The molecular formula of each member of a particular series differs from the above or below it by 1. Now, if you look at this molecular formula here, look at this one here. This one is CH4. Okay, they differ by CH2. How will you know that? C2 minus C, or you can say 2C minus C. What you're going to get is ordinary C. 6H minus 4H. What you're going to get is H2. So they differ by CH2. Or you can also say they differ by molecular mass of 14. Why? Carbon is 12, Abi. That's why carbon is 18. The relative atomic mass of carbon is 12. Why the one for hydrogen is 12 plus 2 is 14. So you can say each member differs by a molecular mass of 14. Or you can say each member differs by a molecular formula of CH2. They differ by 14 grams per mole, or they differ by CH2. If you do the one for the next member, which is number 3, you're going to get the same thing. Okay, so that's that part. Then the next part, which is what I've explained, you can see they differ by molecular mass of 14. Let's explain that now. Compounds that are members of a homologous series they are prepared by using the same general method. So the way you prepare methane the same way, a similar method, because all of them are in the same family. So the way you prepare methane, same way you're going to use to prepare ethane. Then the next one, propane. Just that the reaction rates might be different, like the temperature, the kind of things you're going to apply to make the reaction feasible. But the general method is the same to prepare them. Why? Because they are under the same family. Okay. Now that family is what is called the alkane family. Similar method of preparation. The physical properties such as melting points, boiling points, and density show a gradual change with increase in the formula or molecular mass. So you can see that I've said this one before. The physical property, the melting point, boiling point, is a gradual change as the number of carbon atoms increases. So let me show you from this chart that I made here. Let me just give you an example so you understand it better. So you can see from this page here. Sorry about that. From this page here, you can see from here, the number of carbon atoms here is 1 to 4. That is because the first member was CH4. Second member is C2H6. I told you guys, all these guys here, these 4 members, they are actually used as fuels. They use them to cook. That's because they are gases. You can see that the state in these first 4 members is gaseous. By the time you start going from the fifth member downwards like that, they are liquids. You can see that the number of carbon atoms is increasing. The state is changing. The first 4 members are like gases. The next, like from C5 up to like C17, those ones are liquids. Then from like C18, they become more solidified, as in they are trying to become solids until you get to 70 carbon atoms and so on like that. That's when you start having organic compounds that are solid in nature. Okay, so take note of that. Members of a given series have similar chemical properties. The way ethane behaves is the same way methane will behave. That is why methane, ethane, propane, and butane are actually used as cooking gas. The gas that you buy from your filling station, from the fuel person opposite you, the person selling fuel or gas opposite your house there, the gas you are buying is either it's methane or it's propane or ethane or butane. Most of the time, it's always propane. If you check the container, the normal gas that when you just buy a new gas, you see there propane gas. It is written on it. So it is the first 4 members that actually use as fuel. Now let's take the next one, which is functional group. Functional group is an atom or a group of atoms attached to an organic molecule, which enables the molecule to react in a specific way. Or you can say it's an atom or a group of atoms that is attached to a molecule that helps you to identify the molecule. It's like your surname. When they call your surname, let me assume your surname is Alao Daniel or Alao David. Maybe that's your other brother's name. You are not Alao Matthew. Your sister's name, Alao Fisayo. You can see that all of you are Alao. That means that Alao is your functional group of your family's name. You understand? So all of you have that stuff. Now in organic chemistry, it could be an atom or a group of atoms. It could be a straight line, or you have an atom like a group of atoms like oxygen and hydrogen combining together like this. So when it's a straight line, you notice that it's an alkane. When you see a molecule that is just a chain, that is just like these straight lines, no double bond at all, that molecule is an alkane. Alkanes don't have double bonds. If you draw the structure of CH4, CH4 is just one carbon atom, as you can see above here. Then you just put 4 lines like this and put hydrogen at the 4 points there, just like north, south, east, west. So this is methane molecule. It has only straight lines, not double bonds there. So that means it is an alkane. So you can see it's an alkane. So it does not have any double bonds. So that's that. But if it has double bonds, you call it alkane. Alkene. So alkene can be like this. Alkene have 2 lines in their structure. So you can have something like C, then the rest will not be single. As far as it has a double bond somewhere, then that means it's an alkane. That's what you call it. So alkane is double bond, alkane is single bond. Now what if it has triple bond? So you're going to call it alkyne, as you can see, alkyne. Then if it has OH, which is a group of atoms, you can see atom or group of atoms. Oxygen and hydrogen combining together, you call it an alcohol, which is your normal shepherd, which is found in action beta and Jesse and other stuff like that. So they are all alcohols. If you check their structure, you only see OH there. So you only see OH there. Then you have what is called carboxylic acids. So those ones are COOH. So I'm going to explain to you how to draw these structures later. RCOH is the functional group of what is called carboxylic acids. Okay, so just keep in mind. I hope you are following and you are jotting down one or two things. Okay, this stuff is very simple. Like sincerely, it's very simple. Just get the hang of it and trust me, you'll not make any mistakes. The next part we want to look at is hydrocarbons. Now, hydrocarbons are organic compounds made up of carbon and hydrogen only. You can see the name, hydro and carbon. That means it contains only hydrogen and carbon. So it does not contain any other compound. So, and there are several types. So you have what is called saturated and unsaturated. There are two types of hydrocarbons. Take note, Jamb can ask you in OBJ. They are saturated and unsaturated hydrocarbons. Now, what are saturated hydrocarbons? These hydrocarbons, they are formed if all the 4 bonds of every carbon atoms are joined using a single bond to another carbon atom or hydrogen. So this is what it looks like. It's very simple. A compound is a molecule is saturated if it looks like this. You have carbon here and you have 4 bonds. The carbon is in group 4. Okay, it is tetravalent. It has 4 electrons in its outermost shell. So carbon can form 4 bonds like this. That's the way I'm showing you here. This is how carbon can hook itself to other atoms. So it can hook itself to 4 hydrogen like this. So it has become methane like this now. So it is saturated. That means it is already complete. It does not need any other thing again to form. It already has 4 bonds. It has formed complete 4 single bonds. So that means it is saturated. It has reached its maximum state. Okay. But if it's unsaturated, then it will form 2 bonds in one direction. Hope you are following. So it will form like 2 bonds in one place. But don't forget that it can only form 4 bonds. A single C like this can only form 4 bonds. So this one has already formed 2 bonds here. That means it remains 2. So you can just put one up and one here down. Don't put on that one like this, so it's wrong. Why is it wrong? Because you already have 5. This is 1, 2, 3, 4, 5. It's more than already. Carbon can only form 4 bonds. So this is how it's supposed to be. But you can put it like this. It's also correct like this. So this one is unsaturated because the number of bonds on one carbon is high. It's high on one part. This is carbon atom taking 2. While this one is just carbon atom here taking 1, 1, 1 on each side. The pull from here is equal. Just as if you are standing in the middle and 4 people of equal strength, H, 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 they are pulling you. They are pulling you with equal strength. You know that you'll be confused. You'll be as if you're in equilibrium, under equilibrium rather. But this one here is different. This guy now can be single bond like this. 2 people, one person is pulling it here, but 2 people are pulling it from here. So it will tend to lie or to stretch towards this direction because the equilibrium, the resultant force will point towards this direction where the force is higher. So this one is unsaturated. So you can see the other definition from here. Saturated hydrocarbons have a double or triple bond. So when a hydrocarbon has double bond or triple bond like this, see triple bond like this, it means that it is unsaturated. If it has double bond, unsaturated. But once it has single bond like this, no double bond, it is saturated. Now, there are 3 main groups of hydrocarbons. So you have one is called alkanes, you have alkynes, and alkenes. So you have alkanes, alkenes, and alkynes. So alkanes, single bond. Alkenes, double bond. Alkynes, triple bond. Take note of that. Jamb can ask you. Each family has unique feature or unique physical and chemical properties. They behave uniquely. You know, they belong to different families. If you belong to a family, like you have your own surname, you have a tendency for your brothers and everybody to behave that way. But people that are like in another family, Synergy that as in they behave separately because you guys are not actually related like that. So naming of hydrocarbons. How do you now name hydrocarbons? Now there's something called the IPAC system, okay, which is used for naming organic compounds. The names given to hydrocarbons have two parts. Now, when you're naming your hydrocarbons, there's something called the root name and the suffix name. This root name is like your father's name. Okay, the root name is your father's name. Why this one is your name? So this one here is like first name. This one is like, sorry, this one is like your surname. This one is your first name. So root and suffix. Now the root name are any of these guys here. So the first four members, as you can see here, can be met, et, prop, or boot. These are the first four members. So depending on the family you're talking about, if it's alkane, no, I said alkane, then you're going to say methane, ethane, propane, butane, and so on. But if I'm talking about alkanes, for example, now, I'll just be putting that in at the back. So methane, ethane, propane, and so on. Then if it's alkyne, I'm talking about, then I'm going to say ethyne, propyne, pentine, octane, and so on. So I'm just going to follow that method. Now that's for the parent name. So that's parent name or the root name. Now the primary suffix, which is like the first name, primary suffix are added to the root name to show whether the hydrocarbon is saturated or not. Don't forget, if it's saturated, you're going to put single bond there, and you're going to put ANE because it is only alkanes that are saturated. So alkanes have double bond, so you're going to put ENE. So I'm going to use an example now. Let me use butane for example now. But that's the root name. So if it's an alkane that is saturated, I'll say butane. If it's double bond, I'll say butane. And if it's triple bond, I'll say butyne. So I'll just put YNE at the back. So it's very, very simple once you just understand the structure. And don't forget the number of carbon atoms. So if it has one carbon atom, methane, two carbon atoms, ethane. Just count the number of carbon atoms here. And you can just put the root name from here. And also, from 5 downwards, you notice that it is like all this pentagon. This one is like pentagon, names of polygons rather. This is hexagon, heptagon, octagon, and so on. But from 1 to 4, it is different. So you just need to memorize this 1 to 4. These other ones can be easily memorized if you are using your normal mathematics knowledge, your pentagon, hexagon, and so on like that. So we're going to look at the alkanes now. Alkanes is the saturated hydrocarbon that contains only single covalent bonds. Now, covalent bonds involve sharing of electrons. Once electrons are shared between, like in basically non-metals, carbon and hydrogen. Once they share electrons, they will form what is called covalent bonds. Covalent bonds are formed when they share of electrons. Okay, and it's always formed between non-metals when you have two non-metals. So they might ask you, what's the bond in any hydrocarbon? Most hydrocarbon, the bond there is covalent bond because they sharing of electrons between carbon and hydrogen. So don't forget that. Let's go. So it's single bond. Alkanes have single bonds. So this is the structure here of, let me say, methane. You can see it has only one carbon atom, which is signified with this black circle here. These white circles here are hydrogen. So it has 4. So this is CH4. So the structure of methane. So they have a general molecular formula, which is CnH2n plus 2. So when you apply that formula, take for example, let me just do for pentane. If you do for pentane, this is the 5th part here. Let's put 5 in this formula. Put 5 here. So that will be C5. So 2 times 5 here is 10. 10 plus 2 will give you 12. C5H12. C5H12. That will be the formula of pentane, as you can see from here. That's how they got all these other formulas there. So you can see the name is just the same: methane, ethane, propane, butane, N, like that. It's just going the same way. Then this one is the structural formula. How do you draw these structures? Structure is very, very simple. This is the one for butane. You can see C4H10. So you just draw C 4 times. C. Put single dash in between them all. It cannot be double dash because this is alkanes. Alkanes are saturated. Then just put, after drawing the dash, just put cross like this in each on each of the carbon. There must be 4 lines on each carbon. 4 lines, you can see 1, 2, 3, 4. Each carbon must have 4 lines. That's the number of valent electrons in carbon. Carbon can only share 4 bonds, so you must have 4 lines around it. Then after all those lines, just put H, 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 H on the lines. H, 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 and you get your formula. To get a structural formula, pick it like this. This first part here, pick it out. That will be CH3. Pick this next part out. That will be CH2. I'm getting the condensed formula now. Pick this next part out. That will be CH2. And pick this next part out. That will be CH3. So this formula here is the condensed formula. It is condensed. It is not in like structural form. It is condensed formula of butane. You can easily obtain this formula. Very, very easy. Just check the carbon atom. It's 4. 1, 1, 2, 3, 4. The last one must always end in CH3. You can see this last one is ending in CH3. The first one must also end in CH3. So you can get easily draw the condensed formula for anyone without even thinking too much. Jamb will ask you, what's the condensed formula for pentane? It's very simple. Since it's pentane, you have 5 carbon atoms, Abi. So just put CH3 first at this part. Put another CH3 at this last part here. Then put CH2 in between them. This one will be CH2. You must be 5 carbon chain, so this one 2 already. Put on that CH2. So how many are there now? There are 4. 1, 2, 3, 4. Then just put one more here, CH2. So if I bring it, if I draw it very well, it looks like this: CH3, CH2. So CH2, another CH2 again, another CH2 again, then CH3. You see that the last one, this last one, must always be CH3. What is changing is just the middle there. This CH2, CH2 that will be there. The same thing with decane, no matter what you draw. Just know that the last one will be, the first one will be CH3. Last one will be CH3 too. Just go to the middle and put CH2, CH2, CH2 and count the number of carbons. Make sure it is equal to the name of the root, as in the root name. Okay, so that's how you get condensed formula. It's very, very simple to get. Okay, so I hope you enjoyed this first part of the video, which is the introduction to organic chemistry. I'm going to post more videos concerning this. I hope you understand. Let me know in the comment section. Thank you for watching. I appreciate you guys, man. It's not easy, man. Thank you for watching. I really appreciate you guys, man. So let me know in the comment section which part of chemistry you don't understand, so I can teach you that particular part. I want to cover the syllabus and take some technical topics that you don't understand. So let me know in the comment section. Thank you for watching, guys. I'll see you guys tomorrow with another video. I appreciate you. If you are new to this channel, please click the subscribe button. Thank you for watching. Remain blessed. Peace.